Hello, 8th graders. This is Chapter 7.2a, Multiplying Powers with the Same Base. This is somewhat related to scientific notation, but it does bring us into an area of working with a base number raised to a power called the exponent. If we look in the box, we see 3 raised to the second power. 3 is called the base, and the 2, or the power, is also called the exponent. We can multiply powers as long as the bases are the same. Now, if we look at A, you will note that we have -2 inside parentheses raised to the third power. That means -2 times -2 times -2. Then we're going to multiply that by a -2 raised to a fifth power. That means we're going to multiply it by -2 times -2 times -2 times -2 times -2. It's very important that if you see a negative number inside the parentheses, that it has to be the base inside the parentheses of -2, because there's a difference between -2 raised to the third power, -2 raised to the fourth power, and the opposite of 2 raised to the third power, or the opposite of 2 raised to the fourth power. So make very sure that if you see the base number inside parentheses, that you keep it inside parentheses. Now, if we look at what we really have here, we have -2's. We have 1, 2, 3, 4, 5, 6, 7, 8 of them. So our exponent is going to be 8. Now, if you'll notice, we have a second example. 3 squared, which means 3 times 3, times 3 to the fourth, which means 3 times 3 times 3 times 3. Now, if we really look at this, we have 1, 2, 3, 4, 5, 6. So we have 3 to the 6th power. Now, if we look at the exponents, 2 plus 4 equals 6. Let's look at sample C, example C. We can also use numbers, or letters rather, variables, as our base. Here we have a to the first power times a to the fourth power. So it really means that we have a times a times a times a times a. Well, if we count them, how many do we have? We have 5. A to the fifth power. But if we take 1 plus 4, we will also get our 5. If we look back at example A, if I take 3 plus 5, I get 8. We have certain rules in math, and sometimes they are called the laws of exponents. And when we are going to multiply numbers or variables with the same base, in other words, all -2's, all 3's, all a's, we can add the exponents to give us a shortcut in doing the math. So, if we have 3 squared times 3 to the third power, we are multiplying the same base. We could then add the exponents and get 3 to the fifth power. But if we look on the right side of this rectangle, 3 squared times 4 squared is not having the same base. I can do absolutely nothing to simplify 3 squared times 4 squared unless I want to take 9 times 16. So you have to make sure that your bases are exactly the same. Let's look at sample B, example B. I have 6 squared times 6 to the third. So I would have 2 6's and 3 more 6's. How many 6's do I have? 6 to the fifth power. But again, what is 2 plus 3? 5. In example E, I've seen students who will tell me that it's -4 to the 7th, because we forget that if we don't have a power written down, there is a 1 there. So in this situation, we have -4 inside parentheses to the 8th power, because it's 1 plus 7. You try F. Did you get m to the 12th? Now G, example G, is a little bit more complicated because you have x's and you have y's. Now remember, we have to have same bases. So I can deal with the x's and get x to the 3rd. And then I can deal with my y's and get y to the 3rd. You try H. Did you get A to the 5th times B to the 7th? What happens if my exponent is a variable? We actually do the same thing. We're going to have the base, but we add the exponents. The only thing we can do here, though, is say A plus B. The other skill that they're going to ask you to do is to do greater than, less than, or equal, working with multiplying powers with the same base. Now, sometimes the best thing to do here is simplify, and actually you'll probably have to change the one side to a standard numeral. On the left side, we have 2 squared times 2 to the 3rd power, which is actually 2 to the 5th power. You will have to go to the standard numeral here. 2 to the 5th power is 32, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we are going to have greater than 16. If we look at example K, on the left side, we should simplify that. 6 to the 2nd power times 6 to the 6th power. What does that equal? Yes, 6 to the 8th power. Now, remember from the lesson we had in 7.1b that we compare the exponents. Well, 8 is less than 12 as an exponent. And that concludes lesson 7.2a on multiplying powers with the same base. Today, please respond with the code word raspberries. Scouting out.